Are you able to see the screen?
Yes.
Hi,
Sure.
Saurav. Actually, I'm audible.
Yeah. Yeah, you are audible,
Uh,
Prathamesh.
yeah. So, Saurav, thank you for this session. And by the
Hmm.
way, I'm new to the data engineering. So, yeah, that's
You are
just
completely new
question.
to the data engineering world.
Yeah, because I have knowledge of SQL, Informatica, data warehousing, and all, but
Hmm.
purely data engineering like PySpark and Databricks, I'm completely new.
Okay, okay, sure. So
Thank you.
first let us address why we even need a data warehouse. Okay. So let's get to that question. If anybody wants to answer that, that will be good. From why we need data warehouse. So if any one of you can answer that.
To perform analytical workloads,
So why
analysis
we
part.
cannot perform on RDBMS? MyPass DBMS, so we have DBMS. Why can't we
Reason
perform? Hmm.
reason being, the transactional databases are for performing day-to-day transactional things,
Hmm.
right? If we
Hmm.
are having some transactions, right? Suppose
Hmm.
UPI and all, right? We're making the
Hmm.
transactions, and
Hmm.
these transactions are like upset
Hmm.
operation, so काफी सारा
Hmm.
load पड़ता है. And if you perform the same thing on top of that data warehouse, right? On
Hmm.
that database, तो एक
Hmm.
एडिशनल एनालिटिक्स वाइज जो वर्कलोड, क्योंकि हम उसे बहुत सारे डेटा पे परफॉर्म करेंगे एनालिटिकल वर्क, तो वो
Hmm.
एक्स्ट्रा
Hmm.
वर्कलोड पड़ेगा. So we do not want that database to be involved into it. So what we do, whatever the data we have, we put it in a certain database, और वहां पर
Hmm.
हम एनालिटिकल वर्कलोड परफॉर्म करते हैं. तो हम अपने डेटा वेयर हाउस, डेटा
Hmm.
एनालिटिकल काम और ट्रांजेक्शनल जो हमारे वर्कलोड्स हैं उन दोनों को सेपरेट रखते हैं. We do not
ठीक है.
mix them.
ठीक है. So
Okay.
reason being
ये
it
main.
will increase the load on the RD, basically your RDBMS server. Secondly,
हाँ.
RDBMS for transactional data and these are analytical query that will take more time, right?
हाँ, और एक चीज और भी है कि
हाँ
पहले
जी.
जब पहले एक बात और भी है कि जो पहले के
हम्म.
जो हम डेटा वेयर हाउस के लिए जो हम डेटा वेयर हाउस के लिए यूज करते थे और जो
हम्म.
ट्रांजेक्शनल यूज करते थे, दोनों में कुछ
हम्म.
ज्यादा डिफरेंस नहीं था. दोनों भी नॉर्मल डेटाबेसेस ही होते थे, राइट?
हम्म.
बस डेटा
हम्म.
बहुत सारा डेटा हमारा इकट्ठा रहता था,
हम्म.
और डेटाबेस में ट्रांजेक्शन डेटाबेस रहता था, मतलब जो ट्रांजेक्शन डेटा होता था वो रहता था.
हम्म.
बट विद टाइम चेंजेस आए हैं, बट मेन जो
हम्म.
कॉन्सेप्ट है वो यही है.
Sure.
दोनों को
So,
सेपरेट.
ठीक है. Your
Every
good
can
name?
add, right? किसी
See,
और को कुछ ऐड करना.
I cannot see your name. So your good name?
This is Abhinav.
Okay, Abhinav. ठीक है, Abhinav. Yeah, most of the time, मतलब al- you're almost right. But see, if there is a scenario, let me walk you through a scenario. Generally, what will happen in an interview if he wants to grill you, he will say he runs a company and there are only 50, 60 people which are using their app. So it's an internal app which is being used. Now, in that case, do we really need a warehouse? Only 50, 60 people or more, let's say only 500 people are using that app and it has a MySQL database. Now they want to analyze performance or they want to make some KPIs out of that. So do you think in that case a data warehouse really makes sense?
I don't think so, as we see, because
Mm,
because if you have 40 people using those things, so the data which is generated by them is not so be will not be so
mm,
huge. So we can
exactly.
perform the analytical purpose on top of that. So it's not required,
Sure.
I think.
So sure. So first is volume, basically volume, right? So
Yep,
the
correct.
need of warehouse comes when you have huge volume of data. So that's why warehouse comes in the picture. So you have RDBMS, you have NoSQL DB, and many other type of sources right now. But earlier, RDBMS was the one which started. So how it started? Okay, Bhunesh is there. So let me ask Bhunesh if he wants to take over. Hello, Bhunesh, can you hear me? Hello, Bhunesh.
Yeah, yes, sir.
Uh, Bhunesh, can you want to start with Spark because I think Delta Lake will make sense after this only.
Yeah, sure.
Yeah, please take over.
Is my screen visible?
Yeah, you are visible.
This PPT is visible.
Yeah, absolutely.
Okay. Okay, so I will start with very basic thing. So there are like two types of machine system. The one is the monolithic and other one is distributed machine system. So earlier, what was happened there in the monolithic machine, there were some limitations over the monolithic machine system because the number of machines like only one. So whenever we have a large amount of data like 10 GB, 20 GB, 1 TB, so we cannot vertically scale it because of the physical cost and the machines and the heat dissipation issue. Because of that, we cannot vertically scale only one machine. And apart from there, there were other issues like a single point of failure. So if there is any issue in the machine, so it will be crashed and all your microservices or batch processing will be crashed down. So we have to think about the distributed machine system. So if we compare both of these things in distributed machine system, it is like we are having multiple machines and we can basically scale it horizontally so that if you're, let's say you have a cluster of 10 nodes and these all 10 nodes are horizontal. So suppose one node is down. So my other 9 nodes are already up. So we can use those 9 nodes anyways if the one node is down. So we'll be having services running over there on the other nodes. And apart from that, like we have a highly parallel processing in the distributed machine system. Like nowadays, we see the cloud systems like AWS, Azure, GCP. So all these are on the basis of the distributed computing mechanism. And apart from that, there is no single point of failure in this because we have multiple nodes. So already the fault tolerance property is achieved over there. And it is cost effective if we see the large scalability like having the huge data sets, so it will be cost effective also. Let's say like you want to process 10 GB of data, so you want to have in the monolith system you want to have the 1 GB of 10 machines, but in a distributed it will be handled like in for 20 minutes, so it will be cost effectively uh, in the distributed system. So basically, we have to design the distributed machine system for the large and massive kind of data sets. But suppose if you have a smaller data set, then both will be similar. Can you- yeah, okay. So this was the basic of like why do we need clouds, distributed systems nowadays? Because we have a large amount of data and we want to have the services up all the time and we want the speed also. For speed, we will come to the Hadoop versus Spark also in the next slide. So uh, in the distributed fashion, we have two kind of frameworks we can say. We have other framework also, but at this for the scope of this meeting, we are limited to Hadoop and Spark only. So in Hadoop, basically it was developed by Yahoo and it was like more suitable for a batch kind of processing. So it cannot have the like in machine learning algorithms, it is like iterative process, and in graph algorithms where the data size is big. So second. Yeah. So, like Hadoop, in Hadoop, what was happening over there? It is really slow for the higher data because it uses disk in between. And in Spark, it is like more of a in-memory computation is done because in Spark we don't have any storage kind of thing. Spark is mainly an engine for data processing, but in Hadoop we have two parts. One is like compute and one is storage. So it will primarily use SDFS. Basically, it is known as Hadoop Distributed File System, where the data is replicated across the nodes, and it handles the fault tolerance property by replicating the data. So again, when the data is small, there is no much difference. We can use Hadoop or we can use Spark also. But when the data is increasing, like we have 1 TB of data or 1 petabytes of data, we cannot use Hadoop because after each of the computation, it will go into the disk and it will read again from the disk and write into disk. So the I/O operations will be very high in case of Hadoop. But in Spark, it will be mostly in memory. If we will be seeing the architecture of Spark in the upcoming slides, so we can see that it won't be using any kind of memory. It will just use the cluster of nodes. That memory is used, obviously, but it won't use another extra memory for the writing the I/O and disk. So it is said generally like Spark is like 100 times faster, up to 100 times faster. But for a smaller data set, it is not the case. It is the case only for the huge size data, like in TBs or petabytes. And in Spark, you can say it will support, apart from batch, it will support the real-time analytics, machine learning algorithms, and graph processing. And this fault tolerant property, so SDFS handles this by the replicating the data, but in Spark, it makes the directed acyclic graph. Basically, it creates a lineage over there, and it records the all the planning. So whenever there is a data losses over there, if your application failing, there is a data loss, or anyhow, if there is a data loss, so it will basically using that DAC, it will recompute the data. So the main difference is like Spark is in memory and Hadoop uses disk for the I operations. In the next slide, you can see problem of map reduce. As I already said you, like there are two parts in Hadoop. One is SDFS, basically, which is used for storage, and other one is compute system. So for compute, we have map reduce. So for example, this is your input file where the data is written like dear, beer, etc., etc. So first of all, like we want to count the words. So it is very famous problem in Spark and Hadoop. So what will we do? Like we will be having splitting the data line by line. Then we'll be having mapping. Like for each word, we are mapping it to one so that we can count in the last. And after that, there will be shuffling. So what is shuffling over there? Because like on each local machine, you should having the data for the like you want to group by the data on each word, and then you want to count. Basically, the reduction part is like having one function to make it like localized. So here reduce is like counting. So you will shuffle the data across the network, and there will be a latency also. So basically, when Hadoop uses this kind of strategy, it will be using disk. So there will be higher disk I/O when we are doing shuffling and reduction over there. So after the shuffling, we are doing counting word by word, and it will be the reduction stage only, and then we will be having final result in the last. So it is the process of basically the map reduce. But in a Spark, it is done in some other ways, like it won't be using the disk and all. Certainly, it will be doing shuffling, but we can optimize it. So coming on the next slide, it is like what is the RDD basically in Spark? So RDD stands for Resilient Distributed Dataset. So basically, if we bifurcate the word by word, so resilient means it should be having the fault tolerance property, and distributed means it should be having the mechanism so that we can compute the data in a parallel fashion. And data set, like in general, we have the collection of data. So if we understand the resilient word, uh, So how does RDD make sure that your resilience property is satisfied? So basically, as I already said, there is a DAG of RDD where on the so basically in any kind of graph we have two parts, vertices and edges. So on the on in Spark we have a DAG which is having like on the vertices we have RDDs and the in the edges we have transformations over there. And apart from that, every each RDD will be immutable, so we cannot change any RDD. If we want to make another RDD, like let's say you have X and you want to do X plus 2 over there on an RDD. So X plus 2 will be my new RDD and you cannot modify the existing RDD. So by that, data consistency is maintained over there. So coming down to the point of like fault tolerance. So if the RDDs are immutable, so basically it will create a lineage over there, and it will be a DAC, and after that, uh, there will be some transformation in the DAC. So the lineage will be created using that DAC, and we can recover that RDD. Suppose we have lost some data, we have created RDD1, then RDD2, then RDD3, and somehow we lost RDD3. But Spark knows how to make RDD3 using RDD1 and RDD2. It knows the sequence and all kind of operations. So that's how it has the feature of resilience, and which is like mandatory in the distributed fashion. Apart from that, it is distributed. It means it will allow the parallel processing of the data. Uh, by parallel processing, we mean that RDDs will be distributed and we can compute, we can apply some operations in parallel using some cores and executor. We will see in the next concept. Yeah. So if we see the difference in RDD and data frame, so basically RDD can be like structured and unstructured kind of data, whereas in data frame you will be having structured data. It will be having kind of a table, which generally like people use SQL on the databases and tables. So it will be more like a data frame will be more like a table kind of a structure where you can store structured data or semi-structured data, where you will be having some columns defined over there. You can enforce your schema. Suppose you have a schema ID, name, age, and you want to impose that. So you can impose in a data frame. And in RDD, it is like a very low level functional transformations over there. So if you see any code, like if you want to do group by, order by, in RDD, it is very verbose. You have to write a lot of code for doing some transformations and operations over the RDD. Yeah. Can you repeat?
10 बज गया है क्या?
Yes. Yeah, so I was saying in RDD you have to do a lot of coding for the simpler operations, like you want to do plus, you want to do map, you want to do group by order by. You have to apply a lot of transformations over there, and you have to write a lot of code in whether it's in Scala or Java or Python. But what happens in data frame? It is more like it's more like a SQL kind of expression over there, and it is very high level. Underlying concept is RDD only. Like if you are hitting some data frame API, like you want to do group by, you want to do count, or you want to do collect list, collect sets, this kind of operation. Ultimately, it will go into the RDD part. It will do some transformations like that, but on a higher, it will be provided on a higher level. Right. So, for example, your higher level languages also Java or Python. Maybe their inbuilt functions are written in C or C++, but you are not writing C or C++ directly because you are comfortable writing a higher level function. Let's say the sorted of Python. So you directly use sorted without worrying it is like which kind of sort is sorted is like quick sort or merge sort and what kind of algorithm is written over there. You don't write that kind of algorithm. You just use sorted. Similarly, in that way, you don't go to the RDD and write that kind of lambda expressions over there. You just use data frame API generally. So apart from that, in RDD, there will be manual optimization. It means the coder has to basically optimize a lot for the making the optimization in sense of data. But in data frame, if you are using data frame API of Scala or PySpark, it will be like they will be using some catalytic optimizer, which we can cover in some next sessions because it's all the like a big topic where we have to understand a lot of things. There will be some plannings and all. So for this side, you can assume like it will be a catalyzed optimizer, which automatically creates a optimized plan. Like it will create some logical plan and physical plan. Cost wise, it will choose the most optimized plan. So basically in RTT, there will be no catalyzed optimizer. You have to optimize by yourself. So that is why it is not recommended to write your code in basically RDT. So generally we use data frame API where we have already inbuilt optimization over there. And the last one is like ease of use. As I already told you, like RDDs and operations on RDD, they are like more verbose. You have to write a lot of code. So we use data frame API where it is very user friendly. It is more like a SQL kind of operations there, like select, filter, group by. This kind of operations will be there in data frame API. Just you read the file using Spark and then you do some transformation and you finally write it some in some S3 location or maybe HFS location. So going into the next slide. Yeah, so this is basically the structure of Spark. In this slide, we will learn like how it will process the things in distributed fashion. So first of all, you can see in the slide there are some terms like driver, executor, then worker node, then cluster manager, and deck scheduler. These things. Okay. So what happens like if you are writing anything in Spark? So so first of all, I should tell you the driver and worker. So suppose you have a cluster and you have some nodes over there. So nodes you can assume so there are some machines over there. So to make it simplified, you can consider a node as a machine as of now. But in general, in nodes also we have some machines. So suppose on each node we have some machines and there will be so by the Spark architecture, generally we make one machine as a driver. Any machine can be a driver. There is no issue with that. We just have to we just have to ask some memory. Like we have to define some driver memory, then executor memory. So let's say you have a cluster of 10 machines and you have defined memory of 10 GB for each executor. So the executor node will be launched with 10 GB memory and there will be 9 executor and there will be one driver over there. And in driver, you can demand for any other memory also. Like you can demand for 5 GB also if you have asked the Spark program for the memory of 10 GB for executors. There is no rule that the driver memory should be equal to the executor memory. As per your business use case or as per the demand, you can define the memory. Which we can cover in some next session. Like there is a complex calculation over there, like in how many how many cores and how many workers should be there and executor memory. So there is a complex calculation for that, which we can discuss later. But for the basic understanding, like so, as I said, there will be one driver and 9 executors will be there. So suppose you have written a Spark program, let's say to solve a problem like word count. Okay. So in word count, you basically read the file, then maybe split on the delimiter like a space. You you have a basically column of words, and then you apply some like group by and this kind of thing to count the words. So in Spark, what happens? Basically, if there is a real action, then only a job will be created. Real action means like we have already defined some real actions like count, write, read, show. This kind of operations are the real actions. Until that, like if we have n transformations in between, then sorry, if we have n transformation in between, then basically Spark is lazy. It won't be having any real action until you submit any uh, real action. So basically, if you have some transformation in between, like group by, order by, so Spark will be waiting for the real action to appear in the program. Like in this program, you can see there is rdd.count. Basically, when we have count, it is like a real action. We have to have the data in the memory, and we have to do some transformation. And then finally, we have to count. So whenever there is an action, the job will be created. You can go in Spark UI and you can see that job. So one Spark job will be created over there, and depending on the after the job, you can see this diagram. Basically, in job we have a stage kind of thing, and after the stage we have a task kind of thing. And in Spark, task is basically the smallest unit of execution where the actual computation will be done, and the task will be running in parallel in each stage. Okay. So when my job is created, like when there will be an action, the job will be created. So the question arises when stage will be created. So for stage, we have to see like the wide dependency transformation or program. Now the question arises on wide dependency transformation. So whenever if you can see on the screen, like we have suppose we have 9 executors in this particular program, right? So and my data is partitioned in different ways. One second. Yeah, sorry. So yeah, my data is partitioned in certain ways, and one second. Yeah, sorry for the disturbance. So suppose my data is partition like in HDFS we have by default 128 MB of partition size, and suppose we have a data of like 500 MB. So roughly we will be having around 4 to 5 partition. Let us consider we have 5 partitions. So 5 partitions will be distributed across the executors. And suppose we want to have a count after the group by. So for having the group by, we should have the data of same key. Like in this problem, we have seen the word like beer, car, deer, river. So the all should be on the same executor for the consistent computation. Suppose in one machine you have 2 cars, and in another machine you have 1 car. So the data would be consistent. The final answer should be 3, but it won't be coming like that if you don't have the all the keys on a single machine. So in the wide dependency transfer, what is happening? It will be like shuffling across the machines. So suppose in one executor we have 2 cars. So the third car should be having maybe it will be having in the first executor or some eighth executor. So it should be having on the same local machine. So the data shuffling would be there, and it will be coming into the first machine, right? And after the if it will come in this first machine, we can have the group by, and we can count it, and it will give us the correct answer. So in the wide dependency transformation, there will be shuffling around the executor nodes. But in narrow dependency transformation, there won't be any kind of shuffling. So in case of narrow dependency transformation, we have like a map filter, these kind of things will be there, where we basically don't need the shuffling across the executor over the partitions, because suppose you want to do a map or a filter. So how filter will be performed? Like you said, we want to remove the car from the data. So it will just remove car from the data. It doesn't have to be on the same local machine. All the key should not be having it on the same machine. It will just remove the data of that car, and your work is done. So the shuffling is not required in the narrow dependency transformation, and in the wide dependency transformation, shuffling is required. So to make a differentiator, Spark creates a stage over there. So whenever in our program there is a wide dependency transformation, the stage will be created. Uh, because like we Spark wanted to make a differentiation. So apart from job, it creates a stage over there. So after the stage, we will jump into the task part. So how the tasks are created? Like task is very simple. Like the number of partitions will be equal to the number of tasks. So suppose we have like 500 MB of data and we want to process that in a Spark. So roughly we will be having 5 partitions. If we divide 500 by 128 MB, yeah, so roughly we'll be having 5 partitions. So for 5 partitions, 5 tasks will be created, and in the each executor, let's say in each executor we have defined some cores, like 4 cores we have defined per executor. So in each core, each task will be executed, and we can have the data over there. Like there will be some computation and transformation, which will be operated in the task. Like we want to do some group by count or by. So this kind of transformations will be executed over the task, and when all the tasks are executed, the final result will be written over there. Yeah, so thank you so much. It was the very basic understanding of the distributed computing system, and the comparing like with the monolith, we have compared these distributed machine system. Then we compared, uh, we understood about the Hadoop system. Then we compared Hadoop with the Spark, and we understood about the RTD. Then we compared it with data frame and what is the importance of the data frame over the RTD. And we understood the architecture, the basic architecture of Spark. So in the upcoming sessions, we can go into the depth and we can understand some more knowledge on the Spark internals and the practical things also. Yeah, over to you, Saurabh.
Yeah, sure. Thank you, Ganesh. Yeah. So, so see, my way of basically giving a presentation or telling something or teaching something is I want it to be interactive. Okay. So guys, we I started why we need a data warehouse. So we were having a conversation around it. Somebody answered it that we need it because our transactional DB will be overloaded if we use to query it for analytical purposes. That is good. Then I counter question if my company is only having 50, 60 users, the- what in that case do we need a data warehouse? So to answer that, no, we don't need a warehouse. We can fire our queries directly on our SQL, basically our DBMS, whichever our DBMS we are using. So first thing is volume. That is the purpose. That's why we need our data warehouse. Now, second thing that there are multiple sources of data in an organization. It could be a ERP system, it could be a CRM system, it could be your application data warehouse, application DBs. And so there are multiple sources, right? So to have a consolidated and to have a single source of truth, we use data warehouse where earlier we use ETL process, extract, transform, and load, and directly put our data into our data warehouse. So this has been started in late 90s, 80s, and it had been followed till 2010. And in some of in some of organization which I have worked, they are still using it. This older version of data warehouse, and it works fine for them because they are not having that much number of users who use modern lakehouse architecture or Delta Lake. So now, what was the next stage? Why data warehouses failed? So simple volume, and there is variety of data. Now we have news. Just a minute. Yeah. Now we have basically, yeah, these older data warehouse, they were good with batch processing, which means that all your jobs, all your pipelines, or your ETL processes will start at midnight, somewhere around midnight, 12 or 1, whenever your basically your SAP, which is basically a ERP system, which is synced, or CRM, which is synced. So they will start around 12 or 12:30 and process everything for the last 24 hour or maybe last 2 days. It depends on the business to business how they want to ingest their data or transform their data. Now, the main when data warehouse is being maintained, it is used primarily for BI. In most of the cases, earlier it was used for BI only. No AI, ML, or no data science were there. But then eventually it started being used for machine learning purposes also and for data science also and different aspect of these uh, modeling and everything. And then there are certain limitation to it that first is batch processing only. There is a we do not have a real time processing system. And second thing, it support only relational type, a tabular type of data that only you can term tabular type of data. Later on, Teradata and few other companies they come where they supported JSON also an XML file format, but it was a limited support only. And the third limitation, if your data warehouse is suddenly your user has expanded or there is a sudden spike in growth, then the load on data warehouse will increase and it will eventually process very slow. So to upgrade it, you have that monolithic approach where you buy a new server, where you increase its RAM, where you increase its disk size, and that is quite hectic process and quite expensive. So till now, if you have any question and if you want to add any further points to it, that will be really appreciated. Anyone? Okay, so we are good. So now, after data warehouse, to solve this limitation, then there comes data lake, not Delta Lake, data lake. Data lake is usually called uh, to Hadoop. You have seen Hadoop, the data lake era. So Hadoop was introduced, and what Hadoop does, it stored a file in HDFS. If you have 20 terabyte file, or if you have maybe in terabyte files, so it will store in multiple servers spread across maybe on-prem. Yeah, this Hadoop works on on-prem system. It was not cloud. Basically, it was not hosted on cloud or not working on cloud. So that was one of the drawback of it. But it support parallelism. You have distributed computism and cost effective work. It was cost effective. Still, there were limitations that it lacks asset transaction capability, and it supported some sort of support was there for streaming data, but it wasn't good. And to do programming on Hadoop, you need to be really good at programmer. So, and this Hadoop concept, they basically Google gave to paper on distributed file system and this Hadoop MapReduce framework, and then Yahoo implemented it and they come up with it. Now, to solve this, its limitation of asset property and cloud, not supporting cloud, and the scalability issue that still it's hosted on-prem. And right now also it is being used by most of the Indian companies. Most of the companies are still on it. So to overcome these issues of Hadoop, Spark came in the picture. Uh, Now Spark replaced the Hadoop system. It was on cloud, and it is more than 100 times faster than Hadoop. And in they were quite two, three types of architecture that were being followed with the Spark. So you store your file on cloud storage, S3, GCS, or ADLS, or Blob. So these are the four uh, cloud storages, object storages, which are provided by different clouds, and most of them quite cheaper. Cloud storage is really cheaper. Now you run your Hadoop cluster on basically on Azure. You can run on Azure. You can run on EC2, or even on, they have Dataproc, right? Or Google have Dataproc type of services where you can make a dedicated this cluster, and you can run your Spark jobs on it. What will it do? It will read your file from cloud storage. You read your file from cloud storage, you do your transformation, and you then dump again the transform data into the cloud storage itself. Now, what this system lack the data governance issue. This system lack asset capability. It doesn't promise asset transaction capability. So to overcome these challenges, Delta Lake comes in the picture, and basically Delta table comes in the picture. So Delta was originally created by the people who created Databricks, and Databricks was created by the people who created this Spark. So, and these are the folks, they did their PhD from Berkeley, UC Berkeley, and then this come in the picture. So what Delta promises, it promises asset capability, atomicity, and integrity and durability and continuity. So asset transaction. If suppose what asset transaction means, when you pay someone a money, in layman term, I will explain you. Suppose I'm paying you 100 rupees, and if I have initiated a transaction, either it will be completed or it won't be completed. It won't be, if it fails, it will money will come back into my account. If it is successful, it will whole 100 rupees will be reflecting in your account, not 99.9 or something like that. So these type of issues were solved by Delta table. There were two more technologies which come along, which are also in the same category. These are called open format tables. Delta is one of them. Then uh, Netflix developed Iceberg, which is also similar type of table. It has some basically it is more good for querying and all. But yeah, ultimately they all are Parquet file format, and on top of that there is a log file, which basically has all the details when it was returned, how many files are returned, what was the operation. I will show you later in the demo. So yeah, so Delta Lake. So what basically a Delta Lake you can consider is this, there is this S3 ADLS or GCS layer is there, and on top of it there is another layer which is called Delta Lake. So you are using eventually you are using only cloud storage only, but there is a layer which is provided by, maybe you, if you're using Databricks, then Delta Lake is there. If you're using Snowflake, then Iceberg is there. But on cloud level, it is S3 or ADLS only, whichever cloud you are using. So these three things are there. You have schema enforcement, which make sure that your data quality and integrity is maintained. If you are expecting your decimal value to be 10 places, it should be appearing 10 places only. There should be no E or something like that, which comes when we do transformations. And time travel, if you accidentally do something, I used to work, I think she's in the call also. So we used to work. She called me one day that I have deleted entire data for 1 month. What should I do? So I told them that, yeah, you can restore it. There is a functionality available. Earlier, if you are using older version of you have hosted a cluster on cloud of Apache Spark, and you are using cloud storage to read and then dump back the transform file, and from there you may be inserting it to older technologies of SQL warehouse or data warehouse, and from there then you are publishing Power BI reports using it. So that type of architecture are also being used by some of the Fortune 500, which for which I work, but that is like very old, very archaic. This is most of the companies are shifting to Lakehouse platform because it supports everything. If you have uh, basically a tabular data, semi-structured data, uh, audio, video, anything, you can dump it there. You can extract everything from it. On top of it, it supports vector distributed computing, which make read and write output operations very fast. And it has some features which are beyond the scope of the session, like liquid clustering is there, which is very new. And then there is deletion vector that is also there. But yeah, we will discuss them later. So this is Sparky plus Delta log. Let me show you what Delta logs written. And there is one more thing, like schema evaluation, which I think most of you guys will face in your journey. That suppose if there were 5 columns which are coming from the source system, suddenly there are 6 columns, or one of the columns basically data type or data structure has changed. So these type of issues will arise, and so these Delta Lake or Iceberg, they support schema evolution. You have to basically tweak some options in while writing your data in the table or while inserting the table. Then it will support whatever the new column you are getting. It will have the data from the date you are getting. Earlier option will be marked as null. So this option is given by Delta Lake. And it is really good option. Yeah, it also support real-time streaming. Most of you have used Netflix or Prime, and you've seen how quickly auto suggestions and everything works. So in that case, real time is being used. Like we all have seen Netflix, not Netflix, Hotstar, when IPL or final matches of World Cup stream. So every time some one guy will post on LinkedIn that how Hotstar is doing a great job, so they are able to basically scale their architecture. So yeah, at the end, they are also using these type of lakehouse where they can dump very quickly data and they can simultaneously read and write on the same table. So let me show you one more PPT, which is really good. This will make more sense to you. By the way, these all are open source technologies, not anything proprietary. So yeah, so this is Delta table, and your files will be written into storage. Basically, storage means your cloud storage, any cloud storage. It has file and a transaction log. Now I will show you how transaction logs look like. Transaction logs have 3 types of file. One JSON, then there is one CRC file, which is basically a file which tells that if operation is completed or not. I will show you everything. Wait. So it also supports simultaneous reads and write. So if somebody is writing in the table and somebody is at the same time firing a query which is selecting few records from the table, then it is quite possible. And one more thing I will show you. Let me open data community edition Databricks. Okay. Till now, if anyone of you have any issues, then please let me know. The cluster button. Guys, any question?
No,
Any
Saurabh, great.
negative points of data lake?
Pratmesh, Bhonesh, are you speaking?
Uh, no, Saurabh, great. Thank you.
Okay.
No
Yes, sir.
issues.
I am asking any negative points of delta lakes, like cost wise or something like that.
So cost-wise, I don't think storage is very cheaper cost-wise. It is not that much. But yeah, there is one more issue which I face with the whole ELT type of loading, where you dump entire dump from the basically whatever type of source you are using. You take entire dump and you put it in your uh, raw layer. Medallion architecture, mostly companies are following right now, where you dump entire thing in the raw layer. I think it's a bad practice, to be honest. If you have 120 or 150 or 200, more than 200 columns, and you're taking entire dump of that, that really doesn't. And after that, you are only using 10 or 15 columns. Then yeah, you are just taking. You're just making a process. Basically, it is consuming more storage cost, and yeah, but eventually storage is cheaper, so that's why everybody goes with it. But yeah, it will reduce your time by so much of time will be reduced if you just select few of the columns while ingestion. Just put those columns. Yeah, I just want these 10 columns, which I will be using in my downstream operations. That should be the ideal approach. That should be the approach that I would like to follow. And I have also followed it back, but and it also worked. It doesn't make sense if you are ingesting a table which has more than 200 columns, and after that you're using only two or three, or maybe a couple of columns more. So yeah, that is the only thing. Apart from this, there's no drawback within Delta tables that I feel. If you have anything to add, if you feel there is something which can be added here.
Yeah, I worked on like Hoodie also, which is basically a Delta CDC. So when
Mm-hmm.
there is a, by any chance, there is a corruption in metadata of transaction
Mm-hmm.
logs, you have to like again process
Everything.
because the transaction log is, yeah, log is lost and you have to again process everything.
Yep, yep, yep. I think Hoodie was developed by Uber, right?
Yeah, yeah, not sure of the name, but I have used Hoodie.
I only use Delta and better Wi-Fi, so most comfortable with this only. Mhm. So
Saurav, you mentioned about liquid clustering in between. Like, can you like throw some light what exactly is liquid clustering and how it is this different from the normal regular like cluster node cluster like processing that we are using in the Databricks as of now?
okay, so sure, I will discuss. Before that, I will explain you. So see, clustering, there is first concept of partition by. I think you most of you should be aware, but if none of you are aware, I can explain you what is partition by. Then there comes compact, Z ordering, and optimized command in Databricks. Then cluster by came, and then now liquid clustering or auto clustering is there, which basically select the columns. Right now, it is not in this. I'm not having that in my community edition, but I think DBR 16.3 and above supports that, where you do not mention any columns in the cluster by clause. You just give cluster. You just write auto cluster. You just make sure that auto clustering is on, and Databricks will use some of its AI, own AI, and it will make sure that it will take a note that which columns can be most frequently query on basis of your history or usage of the usage pattern, and it will do clustering on its own. Whenever you are reading or writing, whenever your deletion vectors are there, it will make sure that optimize command is run, and it will make sure that your files are in proper partitions are there. So these types of things will be taken care by liquid clustering or auto clustering.
So as of now, is this particularly tested and like about its accuracy rather than manually and like mentioning the columns, or like is it still in the testing phase?
I think it's still not public yet, but yeah, they are. I have read few documents there on their website, but yeah, it is not fully available. It yet to be released. Right now, they only have cluster by clause where you mention few of column which will be used to query your data frequently, or where you will be using join most. Earlier, you use Z order for that, and right now
Mhm.
they are suggesting to use cluster by clause. But there is one more catch here that cluster by will be using more compute. So yeah, it will be more heavy on your pocket.
Got it.
So let me show you what type of uh, see here I'm creating a table employees. So basic table. Uh, by default, everything you create on uh, Databricks is a delta table. You do not have to mention using delta or something. You can also create iceberg table or hoodie table. You have to mention that on Databricks. Now I'm just inserting few of the values in this table. After that, just showing what's inside it. Now, this is showing where my table is lying. So this is the location of my table where my underlying files are being written. And this is internal table, I mean managed table, which means that underlying location and everything will be managed by Databricks. If you drop this table, everything from this location will be erased. So after that, now what I have written that, yeah, just basically seeing what is in this path where uh, my table is being written. So if you see, I have a delta log, and uh, there are four Parquet files, part files, four Parquet part files, which contains the data. Uh, Basically, I have one, two, three, four. Four insert operations were there, so four files are created here. If you see Snappy Parquet is there, Snappy is basically what to say, a compression format where the size is reduced. And yeah, so this delta log is there. Now I'm running one more command, update command, which is going to update the salary where name starts with A. So if you see here, only two guy are there whose name start with A. So two rows are going to be updated. Now two rows are updated, Adam and Anna, इन दोनों का सैलरी बढ़ गया है. It has been increased by $100. काफी कम हाइक दिया है. Now, if you see here, I have two more Parquet files. Earlier there were four, now I have two more Parquet files. Ideally four ही होना चाहिए था because I have just updated the मतलब I have just updated two records and it created two more Parquet files, right? Now, why this is happening? So for that, yeah, this is the basically a history of the table. What is done on table? First, it was created. Then there were four write operation and one update operation. And what update operation did? It it predicated. I mean, it changed the record which starts with A. That will show on which file said read version 4. See, there is no deletion vector. That's why it's showing the number of removed file is 2. But if you can see, this file was there. What it has done, it has removed this file from the delta log. So this is the delta log. And if you see here, the latest version of delta log is this JSON, fifth one. So every time, whenever you are doing a reading, writing, or anything, it will create a CRC and a JSON file. And this other thing, these are basically cloud level optimization. This might be different from different cloud. So this JSON includes all the details that which Parquet files should it be referring, which part files or which Parquet file it should be referring. See, I have opened it here. So it will tell you that, yeah, remove these files. Remove these files. Basically, it is removing the reference of the files from the JSON itself. It is not deleting them. Hardcode delete नहीं कर रहे हो. That is why it is not deleting. So that if you are doing something accidentally, you can always roll back. So if you roll back, it will go back to the JSON of that date, and it will basically refer to those Parquet file. If you open this fourth JSON, if I open this fourth JSON, there are different Parquet file which are being referred, and it will basically show you data of those Parquet file. Right now you have six Parquet file, but yeah, this fifth is referring to four Parquet file only, and this fourth will referring to different four Parquet file, older four Parquet file. So this is how it is able to do rollback. And the CRC file, it makes sure the asset capability uh, checksum to validate corresponding JSON file. Basically, it makes sure that if your JSON is valid or not, if this transaction happened properly or not, if it failed or something like that. So these are the two files which make sure that, yeah, your asset uh, capability is there and you are able to roll back to the previous version. So this is how it happens. Now, if you have any questions, feel free to shoot. In another notebook, I have shown how to restore a table also. So this shows history. Now, yeah, suppose if I want to show, basically I updated here, which is the fifth version of the table. Now I want to basically show what was the earlier version, fourth version of it. I will just do this. Select star from employees version as of 4. So it is showing previous record of Anna and Adam when their salary was not basically increased by $100. So these are few syntax how you can do that. Yeah, here it is deleted. So, deletion vector different route. Yeah. You can restore your table like this only. So yeah, this was the basic how you do deletion, how you do. There is one more thing. Optimize command is there. So there is a famous problem of multiple small partition files. If you have multiple partition files, small size of partition file, it will basically impact your performance. Read and write operations will be heavy. So what optimize command does, it combines uh, smaller files into a big file. And in most of the cases, it is done automatically by uh, basically Delta Lake. It is you do not have to basically manually do optimize. But if you're using a Z ordering, then in that case you have to manually after every Z order you have it is best practice to use optimize command after every Z order. So like this I have used. So this is how it is written for Z ordering. What Z order will do, Z order will reorganize your file. It will create a kind of an index for ID. It will help you to skip if you have four. As earlier you saw there were four files. Now, if I'm querying for sixth employee with sixth ID, and, and the sixth ID employee lies in fourth Parquet file, it will just directly skip. It will read only fourth file and it won't read the three files. So this is how Z order help. In the same way, cluster also help and partition by which was earlier when Delta Lake was not there. So partition by clause was used. So it was also used in similar manner that they used to basically filter out as much as sooner predicate the joining and everything, filter out the files, skipping reading and everything. So these are the things in the Delta Lake. So I mostly cover most of the things on the Delta Lake. So advanced features like deletion vector and clustering and all, uh, those can be covered in later session or maybe next week's third week of May. So yeah, anything if you want to ask, feel free to ask. So let me ask
Saurabh,
why
can we
Delta? Yeah,
create?
yeah,
Uh,
yeah, yeah, Swipul.
okay, so can we create this delta tables apart from the like data using Databricks?
Yeah, you can
Like,
create it. It is open source only. You can create it. If you want to use
okay,
it with some if you want to use it with um, something else, yeah, you can use it. It is open source. Yeah, you need to be more technical how you are gonna create it.
okay. Like Databricks inbuilt support this
Yeah,
delta table.
because the original creators of Spark created this Databricks. They saw
Hmm.
that Spark is being used by industry and they are how adapted so quickly the adoption was. So that's why they come up with Databricks. And then they saw that there is this problem. They solved it as a Delta Lake, and then they basically sell it as a Databricks. These products is really doing great. If you compare it with other, they are capturing market of Snowflake and Redshift and everything. Mostly companies are working on it only.
Yeah, like if we'll compare this
Hmm.
delta tables with the Snowflake, like Snowflake has multiple thing like optimization thing and everything. So like
Yeah, under
what
the hood,
like where
Snowflake is also
Databricks.
using no. Under the hood, Snowflake is also using this only now iceberg only. Under the hood, they also use iceberg only, which is similar to it only.
Okay,
So
okay,
so it is also an open table format. That's not a proprietary format. You can also use it here. Also, whenever you're creating a table, you have to mention that this table is there is separate way. If I open ChatGPT can show you how to create a iceberg table on Delta Lake. So Databricks supports everything. All three types of table you can create here.
okay, got it.
But uh, I sometimes wonder what is next. See, we have basically lake houses come. What's next? What is gonna be next? So if you think that there could be, this is still some challenges there in these platform or these modern warehouses, and they still need these capabilities. We should have a discussion on that.
Yeah, sir, one question.
Yeah, yeah.
Uh, as we have Databricks, we have Snowflake, and now we are covering Microsoft Fabric. So, in future, what should we learn according to you?
According to me, see, I've been using Databricks for the last 4 years. Okay, so I have migrated SQL warehouses and migrated Green Plum and everything to this only. So I think this is gonna be there for a long time because it supports everything, whether you're AI, ML, Gen AI or everything is there. It supports every type of use case. Now, the problem with Fabric is that I have used Microsoft services and their services are great, but their customer support is really poor. So you cannot rely on it. AWS is amazing. Amazon's service is really amazing. They are really great when uh, if a customer is facing any challenge, they are really great in solving them. Fabric is also good. It is also using this only. They call it. I think they call it One Lake, right? Fabric calls it One Lake. And they
Yes.
are also using Spark only under the hood. Earlier it was called Snaps. Now they have rebranded it and pitching it as a Fabric. Fabric is basically a mature Snaps, right?
And what about the Snowflake? Actually, in my current company, we are using a Snowflake. But whenever
Mm-hmm.
I give some interview, they have asked me question on
Databricks.
database.
Yeah, that is the thing. Also, I have seen that Snowflake has, if you are appearing for Snowflake interview, then there is a soft limitation of 20 LPA that I have faced. But Databricks people get a lot of money. That is also one thing. The problem with Snowflake is that if you're using a Snowflake, you need to have multiple other services. Like it's not a unified platform which Databricks is, which is Spark promises it is. You have to basically take additional services and plug it in with Snowflake. Now, if you're plugging something in Snowflake, there will be a data movement cost will eventually use compute and then it will shoot up your basically bill. That's why if you see Snowflake's market share and even their stock price, that is completely falling from last 5 years.
Yes, yes, yeah. We use Snowflake with Microsoft Azure.
Yeah,
So that's why
yeah, even pushing data into Snowflake is painful.
first we need to push it in a stage, then after.
Yeah, so there are certain limitation with with most of these platforms. One of the painful thing with Databricks is that it force you to use certain practices, which I think shouldn't be used, right? They pitch autoloader that you should autoloader. So that really doesn't make sense if you're just reading a GB file or if you're doing a migration project, Databricks will say just do these and these steps. But yeah, that will impact your business because you have to basically think of from your client or business perspective, right? Uh, because autoloader use a lot of compute. It will scan all of your directory. It will do checkpointing. It will scan your checkpointing location, and then it will ingest the file to make sure that nothing is duplicated or nothing is ingested again and again.
No.
These things
And
are there.
So apart from the official Databricks certification, would you suggest any course or like a good like learning
So
material?
yeah, first I think to get into this, well, you should have a good knowledge on Visit
What
Ganesh
knowledge
Bhai,
are
but
you're breaking?
yeah,
sorry to
Spark.
interrupt, but this meeting will be over in 20 seconds.
Okay, 20 seconds. Sure. Shivam, you can reach out to me separately,
Sure, sure. I'll just
or you can
like
just post your queries in the group. Okay, so I will answer them, or Ganesh
Yeah,
can answer that. Yeah, but Spark is must.
perfect.